Well, I want to thank Jonathan Bartlett and the Institute for inviting me. And the title of my talk is Reconceptualizing the Mind-Body Problem. And it's a kind of a basic talk in that I'm trying to look at some of the fundamental errors that began modern philosophy. There's supposed to be a picture of Aristotle over here, but don't worry about it. Aristotle pointed out in his Politics that a small error at the beginning is comparable in effect to all the errors made later. And so I think that at the beginning of modern philosophy, we have a number of small errors that were made by Descartes and became incorporated in our conceptual space, if you will, and that these errors eventually gave rise to naturalism, and they're still persisting. So Descartes begins his meditation with a quest for certitude, and however desirable that may be, it's a fool's errand. Human beings can only have human knowledge and human certitude. The medieval scholastics recognized that. They attributed to our intermediate position in the great chain of being below the angels and above the brute animals. And they saw also the fall of man as limiting our mental faculties. More recently, research has shown that our brain is only capable of representing 5 to 9 chunks of information at a time. So when we want to consider a complex problem, what we do is we abstract out the features of interest and leave a lot of data on the table. So the omniscience fallacy is basically comparing ourselves or our knowledge to the knowledge of God, as though knowledge has to be perfect, has to have the qualities of omniscience in order to be actual knowledge. And in fact, knowledge names something that human beings actually do. They actually know things. And so we need to apply the term to the way in which humans know things, which is fallibly and in a limited way. So in his quest for certitude, Descartes retreated to the human ego. We all know his famous cogito ergo sum, I think therefore I am, and he felt that that was something that was beyond our ability to doubt. But it isn't. We know, for example, that there are eliminative materialists such as Daniel Dennett who believe that there is no consciousness, that the data of consciousness itself is active. The problem is that Descartes confused knowing and willing. He confused the act of the intellect and the act of will. We can choose to doubt anything, but that's an act of will. Just as going to the theater requires a willing suspension of disbelief, so Cartesian doubt requires the willing disbelief of what we know to be a fact. So Descartes writes that he was in his chamber while he was conducting his meditations. He knew he was in his chamber. There was nothing wrong with his mind or what he knew, but he chose to doubt it. So at the end of his quest, stopping on the thinking ego, he identified his stopping point with himself. It wasn't that he didn't know that he had a body, but that he felt that he could only be certain that he had an ego. And so rather than say, oh, I have an ego as part of myself, he identified his ego with his true self. And that is the fallacy of misplaced concreteness. Alfred North Whitehead points out this fallacy in his book, Science and the Modern Mind. And it's the fallacy of thinking that something which is abstract is in fact a reality. And so what Descartes came to as ego is an abstraction, not the concrete reality of the human being. So then he comes back to the lived world and discovers, of course, his extended body and the physical world around him. And now he has to patch that together with the ego, which he is identified to be himself, and he winds up with two substances, with res cogitans, which is the thinking thing, and res extensa, which is extended thing. And those are the two parts of his body, which are of his being, which he knows he has both of them, but he hasn't got a way of stitching them together. So this mode of explanation that Descartes fell into is materialist. Even though he's talking about res cogitans, the thinking stuff, the way in which he is applying it is using a materialist paradigm. So in the materialist explanatory paradigm, things are only what they're made of, that the whole is the sum of its parts. And so if we're made of thinking stuff and extended stuff, that explains us as human beings. But it really doesn't, because it doesn't explain our unity. If we take this paradigm and apply it to theory, we find that they're generally classified as monistic. If you're a materialist or an idealist or a neutral monist, you're a monist. Or dualistic, which is what Descartes was and a number of other people. And in both of these, we're not looking at everything that there is to be seen, looking at the material of which the being is composed. So in a dualist theory, even though we're talking about res cogitans, we're treating it as a kind of a stuff out of which we're made, and not a human activity of thinking. So this mode of thought leads to reductionism. Why is that? Because physics is the most fundamental science of matter. And so if everything is explained by what it's made of, and physics is examining what things are made of, then everything should be implicit in physics. And in fact, when I was deciding to become a physicist back when I was 18 or 19, that's the way in which I thought. And so physics then should entail chemistry, and chemistry should entail biology, and biology should entail psychology. And this is the reductionist paradigm of contemporary naturalism. The problem is it doesn't work. There are two failure points. One is between physics and chemistry. We can't deduce, in fact, we cannot deduce chemistry from physics. And the other is between biology and psychology. And I'll explain in more detail why this is so. Okay, so first of all, we have the problem of misplaced concreteness. The idea that higher level sciences can be reduced to lower level sciences depends entirely on the fallacy of misplaced concreteness. When we abstract, we fix on some notes of intelligibility to the exclusion of others. As a result, we leave contextual data behind on the table. But the problem is that this contextual data is exactly the subject of the higher level sciences. So for example, if we're considering an electron, a physicist doesn't care whether the electron is in an organic molecule or an inorganic molecule, or whether it's in a living being or a mineral. But those differences, that contextual data, is the very heart of a lot of our level sciences, so that it makes a difference between whether we're dealing with organic or inorganic chemistry or mineralogy or biology. Secondly, the idea of reductionism confuses potency and act. So potency and act are very Aristotelian terms. Suppose that we are considering, if we assume that physics has an exhaustive knowledge of elementary particles and their interactions, all that knowledge would do is tell us whether a material structure is possible. It would tell us nothing of the actual structures populating the cosmos, because physics abstracts away any data that would allow us to distinguish between, for example, prokaryotes and eukaryotes. Higher level sciences, such as neuroscience, need their own methods and data because they deal with subject matter which is abstracted away in physics. Shannon, who was the founder of information theory and has been mentioned earlier today, defined information as the reduction of possibility. So physics, in leaving possibilities open and indeterminate, lacks the information to infer conclusions of the higher level sciences which deal with reality and not possibilities. Biology deals with what the actual organisms are, not what is physically possible to be constructed. Finally, the reductionist scheme can't be executed. First, there are conceptual issues. For example, to learn, and one of them is interactions. To learn how things interact with each other, we have to actually observe interactions. Suppose that we knew all that there was to be known about an electron in isolation. We would not even know that it would suffer electrostatic repulsion in the presence of another electron, because that behavior only emerges in the context of two or more electrons. Nor is it enough only the two-body forces, because meson theories of nuclear reactions tell us that new forces emerge when we have 2, 3, 4, or more bodies. Consequently, we do not know that the description of lower level structures in complex contexts is more than approximate. In other words, we can't tell because we haven't tested in a particular context that our simpler abstract conceptions are going to be accurate when we look at more complex concepts. The second problem is a problem of definition. When Newton wanted to say that he was explaining the tides by the attraction of the gravitational attraction of the sun and moon, he was able to define the tides physically as the motion of seawater, as a periodic motion. And so then he could calculate the forces on a parcel of seawater from the sun and the moon and show how they would move. But when we're dealing with higher level sciences, the concepts that are involved are not concepts which are available to physics. And the reason is that they are concepts which we abstract from the contextual data that physics leaves behind, or the contextual data that chemistry leaves behind. So, for example, if we were to define life as involving imminent activity, there's no way to translate imminent activity into the language of physics. Or if we were to say that awareness is the actualization of intelligibility, we could not apply physics or chemistry to that, because concepts of intelligibility and its actualization and it are not concepts which are available to those sciences, because they're abstracted from higher level structures. Lastly, there are mathematical issues. First, there's no closed form solution to some very simple problems. The problems in physics textbooks are the problems that we can solve. So, for example, the motion of three bodies is not one that can be solved in closed form. So if we have three planets of roughly the same size, we cannot calculate what their paths are going to be, and in fact the problem is chaotic, and which means that even on a computer eventually we will not get an accurate solution. Second, and another example of this, and one that applies particularly here, is that while we can calculate the electronic structure of the hydrogen atom, which has one electron, we can't calculate the electronic structure accurately of the helium atom, has only two electrons. So how are we going to calculate the electronic structure of complex chemical molecules? The programs for doing that are available, but they're approximate, and from the computational demands, they can't even be applied to more than about 5 or 6 or at most 8 atoms. So we can't calculate the structure of DNA from first principles from quantum mechanics. So we can't reduce even chemistry to physics. Because of this difficulty, we have a question here of whether or not the hypothesis of reductionism is a scientific hypothesis. It can't be falsified because we can't do the calculations required to effect predictions about what will happen in higher level sciences. And since we can't do the calculations, we can't test whether our low level predictions are accurate, and that means that the hypothesis cannot be falsified. Okay, so now we're going to move up the scale of complexity to the question of consciousness. If everything can be explained by what it's made of, then surely consciousness can be reduced to a physical basis. Well, this claim goes back to the Greek atomists. It has proved elusive. In support of their claim, naturalists have pointed out the great progress that has been made in understanding neural processing and the brain. But in response, David Chalmers points out that this progress has been on the easy problem of neural processing and not on the hard problem of consciousness, of illuminating how we are aware of the data encoded and processed by the brain. To reinforce this, Daniel Dennett, who died in the war, naturalist, in his well-reasoned but deceptively entitled Consciousness Explained, shows that the data of conscious experience are incompatible with naturalism. And rather than rejecting naturalism as a falsified hypothesis, he chooses to reject the data. So this difficulty can be resolved by applying the principles that we've discussed. And looking at the fundamental abstraction of natural science. So, at the beginning of natural science, we start by focusing on the object to the exclusion of the subject. All knowledge is a subject-object relation. There is no knowledge without a knowing subject and a known object. And Aquinas reflects on this to point out that in knowing the self, we know ourselves through our knowledge of the other. For example, when we see an apple, we know not only that we can see the apple, or that there is an apple, but also that we can see. And in knowing physics, we not only know about the world, the physical world, but we also know that we can know. So every experience that we have has actually two objects. It has the objective object that we are focusing on, so for example, the apple or Venus or Saturn or whatever it is that we're looking at, but it also has information about ourselves as subjective objects. And at the beginning of natural science, we choose to focus on the objective object to the exclusion of the subjective object. So for example, we don't care about the subjective experience of Copernicus or Tycho Brahe or Newton when they observed the planets. We only care about the planets they observed. And this vision, this focusing on the external object, leaves data on the subjective object on the table. And that is the result of the mechanistic focus of modern science. So the result of this is that data is partitioned between physical and intentional data. Science looks at the physical data, but it chooses not to look at the intentional data. And there's nothing wrong with that as long as we're dealing with physical objects. So if we start with a unified human person, what we find out is that people do physical acts and they also do intentional acts. We know things, we believe things, we hope for things, and so on. The physical acts can be understood in terms of physical data that they give rise to, things like mass, composition, structure, and so on. And our intentional acts give rise to intentional concepts such as qualia, which are the of perceptions, awareness, commitments, and so on. So the result of this, if we think about it more abstractly, is that we have a physical set of data which is supported by the naturalistic method, and we have an intentional set of data which naturalism doesn't look at because it is irrelevant to the physical world, or so it's thought. So now we come back to the hard problem. And the hard problem is looking for a subset of physical propositions. It's looking for some physical structure or physical process that will imply intentional conclusions. And so we have these propositions P prime, which are about the physical world, and we want to infer from them all the information that we have about the intentional world. But in data partition, there's no propositions of the form some physical data or physical fact implies an intentional fact. And the reason is that the fundamental abstraction of natural science precludes there being such a proposition. So the result of this is that this first thing that we desire is an impossibility, so the hard problem is a chimera. Now, data partition is not something based on reality, it's based on how we view reality. There's no a priori reason why we have to separate the knower from the known. So Descartes drew the wrong line. Descartes drew a line between thought and matter, but we now know that the brain is very much involved in the mind, and so there is not a hard line between the mind and matter, even though there might be a hard line between intentionality and physicality. So now let's talk about how we can bridge this gap between the intentional and the physical. And the first is Aristotle's discussion of joint actualization. In 3, Aristotle showed that a single act realizes both subjective and objective potentials. The contents processed by our brain start as intelligible, but not actually understood. At the same time, our intellect has the power to understand, but doesn't actually understand until it's informed. Our intellect, being uninformed, cannot inform itself, and the contents, though informative, do not understand themselves. In the single act of awareness, both the potential of the mind to be informed and the potential of the contents to be understood are actualized. So, since we have one act actualizing both a potential of the physical world to be understood and of the mental world to be informed, we have them both operating in the same theater of operations. We can't have the mind and reality, a physical reality, interacting if they don't share a common theater of operations. So that's the first point. The second point is that there's an identity at the heart of knowing and an identity at the heart of willing. The subject knowing an object is identically the object being known by the subject. Saying the subject knows the object is simply another way of saying that the object is known by the subject. Formulate the same reality and differ solely by a shift in mental focus from subject to object. Similarly, the subject willing an end is identically the end being willed by the subject. This identity would be impossible absent a common theater of operation. So again, we have common theater of operation shown by the joint actualization of intelligibility and the capacity of the mind being informed, and the identity of the knower knowing the object and the object being known by the knower, and the same for willing. Finally, there are empirical studies that bridge the gap. In the much maligned area of parapsychology, parapsychologists look at the effects of intentionality on physical processes. And although every time I bring the subject up, naturalists beat on it, no one has a sound methodological objection or a sound data analytic objection to the fact that the results that have been found show beyond the shadow of a statistical doubt that intentions can affect and do affect physical processes. So we have a framework which I'm going to suggest, and that is that we discard the materialist paradigm, the idea that things are explained solely by what they're made of, whether they're made solely of matter or of thinking stuff and extended stuff, as Descartes thought, and replace it with a hylomorphic paradigm. So hylomorphic comes from the Greek word hyle, which is means matter, actually means wood, and morphos, which means form. In the hylomorphic paradigm, basically, matter provides us with possibilities. So physics tells us what kinds of structures might be possible, but it doesn't tell us what kind of structures are actual. Form determines actualities, and so the context from which we abstract low-level structures are determined by form. So form doesn't just mean shape, it means everything which provides a further determination on the possibilities latent in matter. These actualities may be emergent, so they can be emergent in two ways. One is that although they might be ontologically implicit in the way in which matter operates, they might not be. So that the emergence can be ontological. It could be that when we configure a matter in a certain way, that things which are not known and never actualized in matter suddenly come into operation. Or it could be epistemological, that we can't do the calculations. Chaos theory stops us from doing calculations. We have models of neuron response, which are nonlinear, and when we apply them to the brain, we find out that the brain is a chaotic system, which means that small deviations in its initial conditions can give rise to large deviations in its final conditions, and so the emergence could be merely epistemological. But in either case, we need the higher level sciences to study the actualities as opposed to the possibilities provided by the low-level sciences. And they can depend on the context. So when we put a single electron in the context of another electron, we suddenly find that it's repelled, which we would never know outside of that context. And so context can further determine what we've learned out of more fundamental science, from more fundamental sciences. Finally, and I don't have time to go into this, I'm suggesting instead of the idea of a materialist mind, which is made up of its component parts, that we have a two-subsystem mind. One subsystem is our brain, which does data processing, and the other subsystem is an intentional subsystem which provides us with awareness and direction. So hopefully this will get you thinking, and I thank you for your attention.
Okay, thank you. I'll now open things up for questions and unmute everyone. I had one question. You said that the emergent properties, they could either be ontological or epistemological. Would you say that epistemological emergentism is still consistent with a kind of materialistic reductionism?
It's not consistent with reductionism because we can't actually reduce the sciences. If you can't do the calculations, you can't deduce biology from quantum physics. You can't even do the calculations for simple molecules, so doing calculations from physics for DNA is just not in the realm of possibility.
Yeah, but that seems to conflate what I would call like ontological reductionism with epistemological reductionism. So even though we couldn't necessarily do
that is not being able to do the calculations is epistemological.
Right.
The emergence of new properties in new contexts is ontological. So nobody, as I said with my electron example, if you have a look at one electron and all of its possible likes, you'll never know that two electrons repel each other. And in nuclear physics, there are multi-body forces that only come into play when you have 3 or 4 or 5 nucleons. We know that there are physical examples of systems that exhibit new behavior in new contexts. That I would call that ontological, that militates against ontological determinism. I mean, reduction.
I see. Royal Truman, did you have a question? You posted a couple of comments here.
Well, yeah, these are things that are hard to follow because one is not entirely sure one understands what's being said and whatnot. Let me rephrase it. The question was just posed, okay? It's one thing to say we cannot understand or model or from the reductionist level what results. That's one thing. A deeper question, I'm not sure about your model, are the reductionist causes the true cause of things like will? The fact that we don't know the properties that result when multiple, let's say, particles are together, thing. The question is it still the ultimate cause of things like wishes, intentions, and the mental states? What is your thinking there?
Well, I'm a proponent of free will, but it seems to me that I'm also Catholic and I believe in individual creation of the soul. Okay, so just to get my beliefs on the table. But right. I think that from a scientific point of view, you can't distinguish between emergence and individual creation of the soul. You know, if you put together, molecules in a unique way, which constitutes the physical structure of a human being, and you look at all the examples, which are all the human beings on Earth, and you find out that they all have intellect and will, then you can't distinguish that as an emergent property as opposed to special creation of each one with intellect and will, because they don't have any physically discernible or psychologically discernible differences. It doesn't mean that. But the point is that in order to explain something, you can't just wave your hand. You have to actually explain it. If you can't do the calculations, do the deductions, you haven't explained anything. All you've said is, well, I think that, if we put the molecules together this way, that this will happen. But that's not an explanation. The only explanations that, scientists should be accepting are ones that you actually do by, calculating or deducing the consequences of your hypotheses. Mm-hmm. And reductionism is a theory that just doesn't work. I mean, not physically, but intellectually, epistemologically, you can't get from physics to chemistry.
Okay. We also had another question. Sorry, are you still there?
I'm here.
Okay. We have another question in the forum. One person asked, could you speak a bit on how the two subsystem perspective of mind and brain that you mentioned at the end, how to think about, how do you describe the interaction between the two subsystems? And just a second, we're also running short on time, so this will be a last question.
Okay.
On board.
I see the laws of nature as intentional structures. And so I see human intentions as let's say, perturbations on the laws of nature. So my intentions don't exert forces, but they do modify the laws of nature. And you don't need much of a modification of the laws of nature because the brain has evolved as a control mechanism, and the nature of control mechanisms is to take small inputs and make large outputs. So the parapsychological data that I referred to shows within like 15 or 16 standard deviations that human intentions can actually control physical processes. So I think that there's good reason to think that that our intentions do control our physics, and that the thread is to conceive of intentions, to conceive of the laws of nature as one kind of intention, namely the general intentions of God for matter, and human intentions as slightly perturbing them.